So we figured out these z values and the probabilities about them, right? But what does this actually mean? What does this actually mean? So let's go ahead and graph our normal distribution that we have here. That's close enough. So we're going to end up with so there's a couple different ways that we can scale this, right? We can scale it using our dollars, and we can scale it using z. So let's do blue for dollars. Since we used green for the line. And so we know that this mean, right? We were told that this is $1,000. And let's go with that first prompt that we were asked, right? Which is the drivers who earn $1,100. And let's say we're interested, how many people, or what's the probability that you would make above average but below $1,100? So specifically, we're asking what's the probability that you would make the amount between this range? And so we would use another value here. And again, we're asked about $1,100. And so one of the core things that is somewhat difficult for us to understand is, just like in the uniform distribution and just like the discrete distributions that we had before, right? The binomial distributions and so on. The value that's going on here, right? The axis that we're not labeling here, this is my probability of x. But the interesting thing that's happening here is that when we try to figure out what's going on at a specific value, because it's continuous, if you try to figure out what was happening at, let's say $865, right? And you wanted to know what's the probability of somebody making $865. Well, because of the fact that this is continuous, the probability of them making exactly this amount, $865 exactly, is going to be 0. And so whenever we have a continuous distribution, we have to start asking questions within ranges, or we have to ask questions about greater than, how many, what's the probability, or what proportion of people are making over $1,100, right? So that's what we have to keep in mind, that this is telling us the relative frequency of these different amounts. And so when we are calculating the probabilities, and that's why I deleted that axis, because that axis is wrong. That is not the probability. The probability is actually this area underneath the curve. So the area underneath the curve is going to give us our probability. And so anytime we have an area under the curve, that means we need to integrate, right? Now, we're not going to be doing that integration in class. Again, I'll do it as some supplemental videos just to help with understanding it. It's not going to be necessary for the test, but I think it helps to understand things conceptually. But for right now, you just need to understand that it's the area under the curve that's telling me the probability. And so I have a scale of dollars here, and then I can go ahead and I can rescale this into my z statistics, right? And I know that my z statistic at the mu is always going to be 0, right? At the mean, it's always going to be 0. If I need proof of that, I can just go with, okay, if x is, so the z statistic is x minus mu over standard deviation. If my mu is 0 and my x is 0, then we have 0 minus 0 on the top. Doesn't matter what's on the bottom. Anything divided by 0 is 0, right? So this is always going to be 0 just by definition. What about this one? This one, we're going to calculate the z-statistic, which we already did in that last step, and we're going to find that the z-statistic here is 1.00. And so when we find this number, 1.00, right, when we go in that z-statistic table, and we go 0.7, 0.8, 0.9, 1.0, and then we go 0.00, right, and we go down, we find this value here. We find that this value here is 0.3413. And that is the area underneath this curve in between the values of 1,000 and 1,100. So the probability of finding drivers that earn between 1,000 and 1,100 is going to be 0.3413. And we can figure some other stuff about this as well, right? So because of the fact that this is symmetrical, what can I ascertain about this whole left-hand side of this normal distribution curve? It's just 50%, absolutely. So we can go ahead and put 0.5 over here, and then we can make some other statements. We can say that the probability of somebody making less than $1,100 is going to be equal to 0.8413. How do we get 0.8413? Well, we just took 0.5, this part over here, and we added it to the 0.3413 to kind of extend this shaded region out to not just be this initial region, but now have this whole extra part, right? Because this is essentially from everybody making, you know, this is 0 all the way over here, right? Can't make negative money. So this is the distance, this is anybody making from 0 and $1,100 driving for Uber or Lyft. So the way that we read these things is a little strange. We have to start thinking about them in ranges. These probabilities of continuous distributions at certain values end up giving us nonsensical 0 answers. Okay, let's do another example.